So this is a circuit. You see this 4 microfarad capacitor, 2 microfarad, 2 microfarad. This is 4 microfarad, and again this is 4 microfarad. So you have to find out the equivalent capacitance between the point A and B. You have to find out equivalent capacitance between point A and B. Okay. First you think there is a point C, or say C. So first you think between point C and B, what is the equivalent capacitance? So between point B and C, these 2 points, there are 2 capacitors. One is, these 2 capacitors are in parallel. Okay, because 2 microfarad connected between C and B. These 2 microfarad also connected between C and B. This 2 microfarad is connected between C and B. This 2 microfarad is also connected between C and B. So these 2 are in parallel. Since parallel, Cp is equal to C1 plus C2. That's why 2 and 2, 2 plus 2, that is equal to 4 microfarad. That means between B and C, you have to connect a 4 microfarad capacitor instead of connecting 2 microfarad each. So just remove these two, and you connect a single capacitor equivalent, which is of value 4 microfarad. Okay, now you have to find out the equivalent capacitance between A and B. Now between A and B, there are 2 lines. This is one line and this is another line. Okay, so these 2 capacitors are connected in series. These 2 capacitors are also connected in series. Okay, then for the line 1, this is the line 1 and this is the line 2. Line 1 equivalent capacitance is C1. C1 is nothing but the series combination of 4 and 4, and series combination 4 and 4 is 4 into 4 by 4 plus 4, that is 16 by 2 microfarad. So instead of connecting 4 and 4 in series, you remove this 4 and 4 and you connect a single capacitor of value 2 microfarad. Okay, and in the second line also, there are 4 in series. So again C2 is 4 into 4 by 4 plus 4, so that is equal to 2 microfarad. Again this is 2 microfarad. So instead of connecting 4 and 4 in series, you remove this 4 and 4 and connect a single capacitor of value 2 microfarad. Now this 2 microfarad between A and B, they are connected in parallel. Since these 2 microfarad connect between A and B, these 2 microfarad also connect between A and B. Therefore, these 2 microfarad are connected in parallel, because this 2 microfarad is connected between point A and B. These 2 microfarad is connected also between point A and B. Therefore, 2 microfarad connected in parallel. So equivalent capacitance between point A and B, CAB, is nothing but 2 plus 2, that is equal to 4 microfarad, because 2 and 2 are in parallel. So this is our very good problem. Next I am going to solve another problem of capacitance. So next this is a circuit between point A and B. This is 12 volt supply, then this is 8 microfarad and 4 are connected in parallel. So you have to find out the charge appearing with each capacitor. You have to find out the charge appearing with this at 8 microfarad, 4 microfarad, 4. This is again 4 microfarad. So you have to find out the charge appearing with each capacitor. For this, what you have to do, you have to find out the equivalent capacitance, between A and B. Between A and B, you have to find out equivalent capacitance. First, you see these 4 and 4 are in parallel. So then this equivalent becomes this is 12, this is 8, and this is again 8. Okay, this is 8 microfarad, this is 8 microfarad, and this is 12 volt supply, and this is point A and this is point B. Then you see these 8 and 8 are in a series. So 8 and 8 are in series. So CAB, what? CAB is equal to between point A and B, 8 and 8 are in series. So 8 into 8 by 8 plus 8, that means 64 by 16, that is 4 microfarad. That means you connect this as, this is our 12 volt supply and this is our 4 microfarad capacitor. This is 12 volt and this is 4 microfarad. So circuit becomes a simple one. 12 volt and 4 microfarad capacitance. Next, the charge. Charge flows from the positive terminal of the battery Q. Q is nothing but the C effective into V. What is C effective? 4 into V is what? 12 volt. That is equal to 48 microcoulomb. Because 4 in microfarad, since 4 is in microfarad, therefore this is in microcoulomb. Okay, since 4 is in microfarad, therefore this charge is in microcoulomb. Okay, now coming to the main circuit. That means we understand that 12 volts battery supplied total charge Q is equal to 48 microcoulomb. That means from this 12 volt, Q is equal to 48 microcoulomb is supplied. That means from 12 volt supply, from 12 volt battery, 48 microcoulomb total charge is supplied. Okay. Now this charge flows through this wire. That means this 8 microfarad capacitor get charge 48 microcoulomb. So charge appeared across 8 microfarad. Therefore charge appeared across 8 microfarad. 8 microfarad is equal to 48 microcoulomb. Okay, charge appeared across 8 microfarad is equal to 48 microcoulomb. Therefore charge appeared across 8 microfarad is equal to 48 microcoulomb. And then how does this happen? That means this positive charge appeared here, negative charge appeared here, again this positive charge, again this positive charge. That means the charge appeared on this side, 48 microcoulomb, flows through this wire, that means this charge again 48 microcoulomb. Okay, this is the principle. First this 12 volt supply battery supplied 48 microcoulomb. So 48 microcoulomb flows through this wire and this plate getting positive charge. By induction this plate getting negative charge by 48 microcoulomb, and this side getting 48 microcoulomb positive charge. But since this side is connected through this wire, so this positive charge 48 microcoulomb flows through this wire and coming to this wire, and it is divided in two parts. One is Q2 and another is Q3. Okay, since these two capacitor have the same capacitance, since these two capacitor having same capacitance, therefore 48 microcoulomb is divided into Q2 and Q3, and Q2 must be equal to Q3, since these two capacitor have the same value of capacitance. Since these two capacitor have the same value of capacitance, so Q2 is equal to Q3. That means is equal to Q by 2. That means this Q is equally divided between these two lines. That means these two capacitor will get same amount of charge from 48 microcoulomb. That means each will get, that is equal to 4 microcoulomb. So that means this 8 microfarad will have charge 48 microcoulomb, but this 4 microfarad and this 4 microfarad both will get 24 microcoulomb each. So this is our problem. This is our next problem. Next I will go to solve another problem. Now it is another problem. Suppose there are 4 plates, 1 2 3 4, and separation between consecutive plate is D, and area of each plate is A. Then find the capacitance of this combination. Suppose this is plate number 1 and this is our plate number 2. So this is parallel plate capacitor, this is 1 and this is 2. So separation between these two plates is D, and area of each plate is A. Now actually in this is actually represented like this. This is represented like this. So this is plate 1, this is plate 2, and separation is D. Similarly, there are two plates. It forms a single capacitor. There are two plates having separation D. Area of each plate is A, and this forms a single capacitor. But instead of two plates, we have 1, 2, 3, 4 plates. So 1, 2, 3, 4. Okay, 1, 2, 3, 4 plates. Okay, so we have 4 plates. Each plate have the same area A. Separation between consecutive plate is D, and the connection is like that. 1 and 3 is connected to the positive terminal of the battery, and 2 and 4 plate is connected to the negative terminal of the battery. Okay, now what will happen? The charge from the positive terminal flows to plate 1 and plate 3. Therefore, plate 1 and 3 will get positive charge from the positive terminal of the battery. Okay, and plate 2 and 4 is connected to the negative terminal. That's why plate 2 will get negative charge on both sides of the plate, and plate 4 will also get negative charge but on the upper side, because if you consider this side but there is no further plates, so this charge will have no effect. Similarly, if you consider this charge on this side but there is no further plate above this plate number 1, so this charge will have no effect. So the plates are will be charged like this. Plate 1 will get positive charge, plate 2 on both sides will get negative charge, plate 3 on both sides will get positive charge, and plate 4 on one side, we consider only one side, will get negative charge. Now what will happen? Plate 1 and 2, plate 1, this side is positive. Okay, this side is negative, and this is connected to the terminal A, and this is connected to the terminal B. It is positive and this is negative. This is plate 1, this is plate 2. This is one capacitor. Now 2 and 3. Plate 2 is connected with the negative terminal. Plate 3 is connected to the A. Plate 2 is connected to the terminal B, negative terminal. Plate 3 is connected to the terminal A. So this is another capacitor. This is 2 plate and this is plate number 3. Again, for the third capacitor, this is plate 3, which is positively charged, and it is connected to the terminal A. And for plate 4, number 4 plate, this is negatively charged and this is connected to the B. So actually this arrangement look like this. If we simplify this arrangement, this is look like this. So here actually we see from 4 plates, from 4 plates we get 3 capacitor in parallel combination. How do you connect the plates? Alternate plates are connected to the one terminal of the battery, means positive terminal, and other alternate plates are connected to the negative terminal. That means 1 and 3 connected to the positive terminal, 2 and 4 connected to the negative terminal. That's why from 4 plates, from 1, 2, 3, 4 plates, we get 3 capacitor, 1, 2, 3. That means from 4 plates connecting alternately positive and negative, we get 3 capacitor. Therefore, if we have n number of plates connecting alternately positive and negative, then we get n minus 1 number of capacitors. Okay. Now solving the equivalent capacitance. Since each plate have a separation D and each plate have area A, therefore each capacitor have the same value. Each capacitor have the same value of capacitance. Since each plate have the same area and the separation between any two pairs have same, means D, that means each capacitor have same value of capacitance, and since they are connected in parallel, therefore equivalent capacitance becomes 1 2 3, so 3C. So if you have n number of plates, then there are n minus 1 number of capacitors, and then equivalent capacitance becomes n minus 1 into C. Now what is the value of C? C is the effective capacitance of any capacitor. That means between plate 1 and 2, or between plate 3 and 2, or between plate 3 and 4, etc. So effective capacitance C of any capacitor is nothing but epsilon naught into A by D. Effective capacitance of any capacitor, individual capacitor, is epsilon naught into A by D. Therefore equivalent capacitance becomes n minus 1 epsilon naught A by D. So this is our problem, and this is very important problem for the competitive exam. Only you have to understand, or you have to keep in mind that alternate plates are connected to the positive terminal and negative terminal. That means if you have 4 plates, then 1 and 3 connected to positive, 2 and 4 connected to negative. If you have 6 plates, then 1 3 5 connected to positive, 2 4 6 connected to negative. From 4 plates we have 3 capacitors. From 5 plates we have 4 capacitors. From n plates we have n minus 1 capacitors, and the equivalent capacitance becomes n minus 1 into C. C is the capacitance of single capacitor of the combination. Okay, so this is a very important problem, and you have to understand it very carefully. Okay. So I'm doing 3 problems which are very important for competitive exam and also for the board exam. Now I am doing another problem, force between two plates of capacitor. Okay, now we have, this is a single plate, this is one side is positively charged, so this plate is this plate one side is charged, say total charge is Q and area is A, then charge parent area sigma is equal to Q by A. One side is charged, and since the plate, conducting plate, only one phase have charge, so this plate will behave as a sheet of charge. And since we already understand, for the sheet of charge, the electric field at a distance, a small distance, electric field there E is nothing but sigma by 2 epsilon naught. You understand? We have already learned this thing, that for a sheet of charge, electric field in front of the charge sheet is E is equal to sigma by 2 epsilon naught. This is electric field due to this sheet of charge. This is a conducting sheet. Why sheet? Because one phase is charged, other phase is not considered. Only front phase, this phase is charged, only this phase is charged. So this is behave like a sheet of charge. So electric field due to this sheet of charge at this point E is sigma by 2 epsilon naught. And since electric field outward, because this is positively charged, so this is in this direction. Now if you place another plate which is negatively charged, and this negative charge faces this positive charge, how much charge? Same charge Q, area A. Similarly here also the negative charge density sigma is also Q by A. Okay, then this negatively charged plate will be attracted by this positively charged plate towards the positive charge plate. Okay, since it is negatively charged, therefore this negatively charged plate would be attracted by this positively charged plate towards this positive charged plate, and the force is nothing but the charge on this plate Q into electric field. And what is Q and what is E? Is sigma by 2 epsilon naught. And what is sigma? Sigma is nothing but Q by A. Putting the value or Q is equal to sigma by A, anything. Q is equal to sigma into A into sigma by 2 epsilon naught. Here I substitute Q by sigma into A. Then what will happen? What will be their expression? Expression is sigma square by 2 epsilon naught into A. This is our force, sigma square by 2 epsilon naught into A. Therefore force per unit area, that is sigma square by 2 epsilon naught. This is the force per unit area on the negative plate. This is the force acting per unit area on the negative plate. This is the force acting per unit area on the negative plate. Similarly, the negative plate will attract the positive plate by the same amount towards itself. So these two plates are attracted by this force, and these two plates will be attracted by this force towards themselves, and the force acting between them per unit area is sigma square by 2 epsilon. I think you understand. First, what we have to do? First, this is a sheet of charge. One face is charge, therefore this is a sheet. Charge per unit area is Q by A. Therefore, for the sheet, the electric field, this point is sigma by 2 epsilon naught, and it is in this direction. Now we place another sheet of charge whose front face is charged by the same amount Q, and since the area is same, therefore sigma is also same, Q by A. Okay, since this is a negatively charged, therefore this negatively charged plate will be attracted by this positive plate towards itself, and the force is nothing but charge into electric field, charge into electric field. Putting the value of electric field, this is electric field. What is charge? Charge is nothing but sigma into A. What is charge? Charge is nothing but sigma into A. The sigma into A into sigma by 2 epsilon naught. This is E. Calculating the value, F is equal to sigma square by 2 epsilon naught into A. So force per unit area, sigma by 2 epsilon naught. What is the value? This is for the force acting on a negative plate. This is for the force acting on a negative plate. Similarly, according to Newton's third law, this negative plate will also attract this positive plate towards itself. That means both the plates will be attracted by each other towards themselves. Therefore, these two plates try to come closer and closer due to this force of attraction, and the force of attraction acting between these two plates is nothing but sigma square by 2 epsilon naught into area A, and the force per unit area between the two plates is sigma square by 2 epsilon naught. And this is a very important problem for our board exam, and also for the competitive exam. You have to find out the result. Just you have to remember the formula, the data given, putting the value of putting the data, you find out the force acting between the two plates directly from the relation. Okay, this is for today's lecture on capacitance. I think I have done a lot of problems in capacitance. Next day, I will try to upload a few more problems in capacitance. Till then, bye. Try to understand, subscribe my channel so that you can get the problems which I will upload in future.